அதே மாதிரி நான் திரும்பியும் வந்து சொல்றது வந்து நான் உங்க பின்னாடி வர்றதுனால உங்களுக்கு பிரயோஜனமே கிடையாது. என் பின்னாடி நீங்க வந்து என்ன வந்து நோய் 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 எனக்கு இந்த பேப்பர் நீங்க கொடுத்துருக்கீங்கல்ல, நான் வந்து இந்த டேட்டா இது பண்ணணும், அது பண்ணணும், இது பண்ணணும்.
Hello. Hello.
Yes, sir.
Yeah, I'm
Yes, sir.
audible. Yeah, okay.
Yes, sir. Yes, sir.
So is my screen visible?
Yes, sir.
Okay. I'll be talking to you about functional groups. Okay. So can you tell what are functional groups? You might studied about various functional groups, right?
எப்படி அந்த பயோஃபிலிம் செல்ஸை டிஸ்கஸ் பண்ணி செல்ஸ் எடுக்கிறாங்கன்னா அவங்க கொடுக்கவே இல்லைன்னா அதுதான் இன்னைக்கே நம்ம பேசணும். எப்படி அந்த செல்ஸஸ்
Am I audible?
அதை வந்து எப்படி டிஸ்கஸ் பண்றாங்க ஒரு வகை என்னன்னா அதை ஸ்க்ரேப் பண்ணி எடுத்துட்டு
Yes, sir.
ஆர்டிஸ்ட் பண்ணலாம்.
So I'm asking some question, very fundamental, very basic question. Even the 7th standard, 8th standard students can answer nowadays. What do you think are called as functional groups?
Hydroxyl, amino group, phosphate,
Hydroxyl, amino.
phosphate.
These are different types of functional group. I do agree with you, right? So my question is, can you define what is a functional group? Okay, so we will take some example, right? We'll take some example. And I am going to tell one drug molecule. You may note it down. The name of the drug molecule, it is called as indomethacin. Okay, just note the name of the drug molecule. So my question is, what for this drug molecule is used? And second question is, what is the structure of this drug molecule? So can you note down in your notebook quickly? You can do Google search. You can find. So what for this molecule is used, and what's the main what's the structure of this molecule? Can you check it?
Reduce fever and pain.
Reduce fever and pain. Okay. Any other answer? I request everyone to do the search, right? So it won't take much time. So can you tell what's the main function of this molecule before going for the structure?
Anti-drug, sir. Inflammatory.
Okay, Inflammatory drug molecule, right? Okay, it's kind of anti-inflammatory drug molecule. So now coming to the structure of the molecule. So how many of you are using a mobile phone, or how many of you are in your laptop?
I'm using mobile phone, sir.
I just need rough number. Maximum of you are using mobile phone or laptop?
Mobile.
Okay, so okay, so anyway, just note on one software, right? So if you have laptop, you just try to install the software. It's called as Marvin Sketch. I thought, no, if you are using laptop, I thought of asking you to install the software anyway, right? So I show the demonstration of this software. I request everyone to install the software on Windows or Linux machine. Okay, I think both the versions are available. Even if you have Mac computer, you can install the software. And this is the software. Okay. So once if you install the software, you can see this is the front end of the software. So we're going to learn about many structures of the drug molecule. So we can easily draw the structure of the molecule using the software. Just go to this structure option, name to structure, right? So what's the name of the drug molecule I said? Can someone? Okay, I'm just typing the name, INDOMETHACAN, right? So this is the name of the drug molecule. So just import. Okay, this is the structure of indomethacin. Okay. So the question is, can someone tell what are the major functional groups which are present in this molecule? I'm again showing the structure of the molecule. So the question is, what are the major functional groups which are present in this molecule?
OH, sir. COOH.
COOH. Yeah, COOH is the atom, group of atoms, right? So what's the name of that functional group? I'm asking the name of the function. Okay, so this region. Okay, this region is carboxylic acid. Like that, do you find any other functional group in this drug molecule?
Methyl group, sir.
So you mean this as methyl or this as methyl?
As the one which is near to carboxylic acid group.
Okay, so okay, this is methyl, right? I hope the cursor is visible, right? Is my
Yes,
cursor
sir.
visible? Okay, so can we call this as methyl group or not?
No, sir.
Alkoxy group, sir.
No. Alkoxy
Alkoxy.
group. Okay, so you mean that we cannot call this as methyl, right?
Yes, sir.
Okay.
Yes,
so any other functional group do you find?
Ketone, sir.
Ketone. Where it is present?
C double
You
bond
mean
O.
this group?
Yes, sir.
Is this you call it as ketone, right?
I think, sir. Not sure, sir.
Okay. Expecting answer from everyone, right? It's a very fundamental basic question. Any other functional group, or if it is mistake, you can give the correct answer.
It is amide group, sir.
Which one? It's not ketone, it is amide.
Yeah.
Okay, so you mean that you are including this nitrogen also part, right?
Yes, sir.
To call it as okay. So any other functional group, or
Chloride, sir.
so you mean this Cl, right?
Yes, sir.
Okay, so this group you mentioned, this you already mentioned, this you already mentioned, this you mentioned, this you mentioned, this you have mentioned, right? So apart from that, any other functional group is there? Any other functional group. I just save it as image. If someone can answer. Aparna.
Sir,
Yeah. Can you tell any other functional group is present? I think 2. Hydroxyl. Okay, so let me bring the picture here. Yeah. So is the structure visible now?
Yes, sir.
Okay, so what I'm going to do is, I'm going to label the various functional groups which are present in this molecule, right? So let me start with this. So this group, what you have said, this group as?
Carboxylic acid group.
Okay, absolutely right. This group we can call it as carboxylic acid. I just want to go slow, right? So because these are fundamental of medicinal chemistry, right? So I don't want to rush. Okay, so next is, so what's the name for this group? Somebody told. Somebody told, like, can you say again? Somebody named this functional group. Okay, alkoxy, right? Okay, so can we say it as a methoxy?
Yes, sir.
Yes, sir.
Is it right name? Okay, because alkoxy is very general name for the functional group. So here the alkyl group is methyl group. So we have to name it as methoxy group. So apart from that, any other functional group? So somebody said this as, what's the name for this? We have
Chloride.
chlorine. Okay, we cannot call it as chloride. We have to call it as a chlorine atom is there. Then, so anybody know what's the name for this specific functional group? So this is called as a carbonyl group. It's called as carbonyl functional group. Then, so this group is methyl group, already told. Okay, now the question of interest is there any other functional group apart from what is labeled here?
Sir, I don't know whether it's
Functional
correct,
group?
but will that benzyl, that benzene ring, would that also be counted?
Clearly visible. Am I audible?
Sir, I don't know, so your voice was stuck, so we weren't able to hear properly.
Sorry?
We weren't able to hear properly, sir. Could you repeat?
Okay, so this labeled part is visible for you, right?
Yes, sir.
Okay, so can you tell what is this functional group? Can you guess what is this functional group? I have labeled some part of the structure. So the question is, what is the name for that functional group? See, I'm asking what is the name for this functional group? That's all. Very simple question.
Sir, one doubt, sir.
Yes.
Sir, why should not we include that nitrogen, sir?
Nitrogen. I'll come to that. Okay, that's not an issue. We can include.
Okay.
You just answer my question first. I am moving, from one part of the structure to another part. I'll come to this part. We had to answer that. I'll answer that. No issues, right? So now the question is, what is the name for this functional group? It's a very common functional group. You can guess. You can make. Huh?
Propane.
See, this is not the original molecule. This is so here we have the structure like this. This is the original structure. What is the name for this functional group? Any guess? Any idea? If you don't know, you can tell, right? So don't need to take too much time.
Sir, just a guess.
Yeah.
Sir. Is it acetate?
Huh?
Sir?
Acetate.
Acetate.
No. Only this part. I'm not including that CO group. Only this part.
Alkane.
Some closer answer. What's the name?
Alkane, sir.
This is a very general term. Alkane, alkene, alkyne, or very generalized name.
Propane.
No. Okay, so this is called as methylene. Okay, you may note it down. Definitely, you would have studied about this in your 10th standard or 11th standard organic chemistry. This is called as methylene group, right? So methylene group is this CH2. Okay, this CH2 is called as methylene. The CH3 is methyl. Everyone said very, correctly about the methyl. So if you have CH2, it's again a functional group called as methylene group. Okay. Understandable?
Yeah.
Okay, so everyone forgot about this functional group. Don't you think this as a functional group?
Phenyl.
Huh?
Phenyl group, sir.
It is called as phenyl, right? So this is also another functional group, right?
Yes, sir.
So phenyl is another functional group you have missed in the structure. So why can't we call this group as a specific functional group? Anybody guess what is this functional group? Anybody make a guess? This is a very important functional group in your 11th standard, 12th standard, state board examinations. What's the name? A 6-membered ring which is attached to 5-membered ring, in which the 5-membered ring is having one nitrogen atom. What's the name for this functional group? So even this functional group is present in one of the 20 amino acids that makes protein. What's the name of this functional group? You can make a guess, or you can tell you don't know. At least I'll be answering.
I don't know, sir.
Okay, I assume that nobody don't know. So this group is called as this is very common functional group called as indole. Do you remember? This is one of the very important functional group in organic molecules, right? So this is present actually in the ring system. So we cannot, if it is not a ring system, we can call this as a amide functional group. As this is attached to ring system, we cannot consider this nitrogen along with this double bond O to say it as amide. That's not correct way to define the functional group, right? So that's why I didn't include the nitrogen, but we can include this 5-membered ring and 6-membered ring. We can consider it as a separate functional group called as indole. Okay. So far what we learned is that if you take any drug molecule, so we have taken one example, and the example is, what's the name of this molecule? What's the name of this molecule? Okay,
Indomethyl.
Methacin. You have to remember the name. When time goes on, you have to remember the structure of all the drug molecules that we discussed, right? So the point is, so why this functional group is important? So what's the need for studying about functional group? What's the purpose of studying about functional group? So if you take any drug molecule, it is made up of different types of atoms. Okay, so some group of atoms that forms the functional group. So if you take the chemical reactivity of the molecule, or if you take the physiochemical properties of the molecule, right? So in our case, the drug molecule. So everything which is mainly depends upon the functional group that is present in the molecule, right? So in terms of drug design, some physiochemical properties are very important, which decides the solubility of the drug molecule. Okay, so we already discussed about ADMET, right? So ADME. So 4 important parameters which are studied under pharmacokinetics, pharmacokinetic parameters, also pharmacodynamics and toxicity. So all these are considered as very important properties related to drug molecule, and these properties are decided only by the type of functional groups which are present in the drug molecule. Okay, so what functional group present in the molecule, that is going to decide the solubility of the drug molecule, that decides the absorption, distribution, metabolism, excretion of the molecule. So that also decides to which receptor it should go and bind to produce the biological response. Also, the toxicity of the intaken drug molecule is decided by the type of functional group which is present in the molecule. Is it understandable?
Yes, sir.
Okay, so if you want to make any guess, or if you want to understand very detailed about the pharmacokinetics, pharmacodynamics, or toxicity of the drug molecule, first thing what you should know is that if I show any structure of any drug molecule, you could able to tell at least what are the major functional groups which are present in the drug molecule, and how those functional molecules may affect the pharmacokinetic and pharmacodynamics of the drug, and how it can be related to the toxicity of the drug molecule, right? So that's why we should have very good knowledge about at least the commonly present functional groups in the drug-like molecules. Okay. So I just want to take some example, right? So a few more example to make you to understand or realize that why functional groups are important. Why we have to always remember the different functional groups, right? So one example is, so I'm just taking another example as aspirin, because this is a very commonly used drug molecule. So what's the biological action of aspirin? Many times we discussed, right? What's the biological action of aspirin?
Painkiller.
Reduce pain.
Painkiller, right? So I'm going to draw the structure of aspirin. Yeah, I highly recommend the software. So whenever you have time, you just install the software, right? Because every time we cannot check the structure in internet. This is a structure of aspirin. So I'm going to just make copy of this aspirin. Export image, and I'm just giving aspirin as the name. Okay, so let me import this to the document. Okay, insert image, a picture. Yeah, so desktop. Okay, desktop aspirin. Okay, so quickly, can you tell what are the various functional groups which are present in aspirin?
Carboxylic group.
So we can say this group as a carboxylic group. Absolutely right. So let me write carboxylic group. Yes. I am not expecting answer from only one student. Everyone can participate because the structure is very simple. Almost everyone can tell what are the various functional groups which are present. Yeah. Next functional group is
Phenyl.
Ester.
Ether.
ether. Which group do you say as ether?
CH3 double bond.
So can you tell what is the general formula for ether? C
RO
R. So okay, RO
R dash.
R dash, right? So which group do you call it as ether here? So you mean this is RO R dash? Am I right? Who said ether?
Sir, Gautam sir.
Am I right? Is my label right here? You mean this is ether, right?
Sorry, sorry sir, wrong sir.
Yes, sir.
I'm not. Okay, COOR. You mean COR? What's the general formula for ester?
Yes, sir.
What's the general formula for
COO
CO
R C O O R dash.
RCOOR dash? Am I right?
Yes, sir.
So if we take this is R COOR dash, then this entire group should be called as what?
Benzene.
This entire group ester, right? So okay, fine. So what is this functional group?
Benzene, phenyl.
Okay, phenyl, or we should not call it as
Benzene.
benzene. It's a phenyl. Okay. So these are major functional groups. Am I right? So if I want to write a functional group for this alone, what's the name of this functional group? I don't want to consider this, but methyl, right?
Methyl.
Okay. So
Methyl.
can you tell what's the name for this specific functional group?
Carbonyl.
Carbonyl. Absolutely right. Carbonyl. And what's the name for this specific functional group? ROR dash.
Ether.
Ether, right? So different ways we can define the functional group, right? So no need to worry about that, right? So slowly we will understand, right? What's the best way to define the functional group? Okay. So okay. So the question of interest is, okay, I just remove everything. Okay. So as I said that most of the molecular properties are related to the type of functional groups which are present in the molecule, right? So my interest is, solubility of this molecule. So can you make a guess that whether this molecule will be soluble in water or not? That's my first question. If you say it can be soluble in water, how do you say that? If no, what's the reason for that? Again, I repeat my question, whether this molecule, aspirin, will be soluble in water or not. So if I take water as the solvent, if I try to dissolve this molecule in water, will it get soluble or not?
Sir,
Yes, sir.
it's slightly soluble, sir.
Okay, the first answer I got is yes, and the second answer is it may be slightly soluble. So let's go for others' opinion also. Slightly soluble. Any other answer from any other student? The next possible answer is no. Okay. So who said yes? Who said yes? The molecule will be soluble in water.
Sir, Subhaschandran.
Can you tell that? How do you say that the molecule can be soluble in water? How do you say that aspirin can soluble in water?
I don't know it's correct, but there is OH group, so that it may soluble, sir.
Okay, your answer is based on the functional group, right?
Yes, sir.
Okay, so based on the functional group, you guess that the molecule can get soluble in water. Am I right?
Yes, sir.
It's not wild guess, right? So your guess is just based on the functional group. Am I right?
Yes, sir.
So who said slightly soluble?
Sir, Aparna, sir.
This molecule can slightly soluble in water, not completely.
Not completely. It's again based on functional group.
Yes, again it is based on functional. I'm not saying whether it is right or wrong, right? So based on what you are answering, that's the point, right? Okay.
And functional group, which
Okay.
can it can interact with water molecules too.
Okay, so can we say that the functional group plays important role in water solubility now?
Yes, sir.
Yes, right? Okay, so basically we can classify this functional group like a polar functional group and non-polar functional group. Okay, if the amount of polar functional group is very large, if more number of polar functional groups are present, then we can make a guess that the molecule can get soluble in water. Another hand, if the non-polar functional groups are, present, if more number of non-polar functional groups are present comparing to the polar functional group, then we can guess that the molecule has more chance to get soluble in organic solvent. Okay, if we find equal proportion of polar functional group and non-polar functional group, we can guess that the molecule can be partially soluble in water and partially soluble in organic solvent, right? So here the another question is, we will take the same example. So can you tell which functional groups are polar, which functional groups are non-polar? I'm using the same example, aspirin, very simple structure. So can you tell which phenyl ring is
soluble?
No, my question is simple. Which functional groups are polar in this example and which functional groups are non-polar? That's all. We are going to classify the functional groups into polar and non-polar. Anybody can answer. You have to tell that which of these functional groups are polar, which are non-polar. That's all. Yes.
Sir, I'm not sure, but the group with OH is polar.
Again, you should not tell OH, right? So you make it as a functional group. So can we take this as COOH? Okay, so you mean that COOH, right?
Yeah.
Is it polar or non-polar?
Polar.
It is polar. Okay, yeah. It's a polar functional group, right? So like that, can you make the classification further? We have few more functional group in this.
Phenyl group is non-polar.
So, okay, phenyl group, I make it as non-polar, absolutely right. So this is a non-polar functional group. What about the rest? What's the name for this functional group?
Ester, sir.
If we include this also, we can call it as a ester. You should not get confused. If this is R and this is R prime, okay, we had to include this for ester. Okay, any idea whether this part is polar or non-polar? We have strong electronegative group. And what about this methyl group? Is it polar or non-polar? Is it polar or non-polar? This methyl group.
Non-polar, sir.
This is non-polar, right? This is non-polar. What about this COO, this group? Is it polar or non-polar?
Polar.
It's a polar group, right? Okay, polar, right? So this is the way how we can classify, a polar and non-polar functional group, and the number of polar and the number of non-polar functional group. See, this lecture is the base for the next lecture, right? So I'll be, talking more about, the pharmacological aspects of the functional group. I just want to introduce the various functional group in this lecture, so we can classify the functional groups into polar functional group and non-polar functional group. So they play important role in the solubility of the molecule. They decide the solubility of the molecule. Again, I repeat, if more number of a polar functional group is present, we can expect the molecule to get soluble in water. If more number of non-polar functional group is present, we can expect the molecule to get soluble in lipids or organic solvent. If there is a kind of balance between polar and non-polar functional group, we can expect the molecule to get soluble in both aqueous and organic solvent. Okay, that is called as a partial solubility, right? So okay. Okay. So now I'm taking the same example. I just erase whatever we have discussed, right? How this functional group is going to affect the pharmacodynamics of the drug molecule. We can use the same example, right? So what is pharmacodynamics? If you respond, quickly, I can go a little fast.
Action of drug to the drug.
Action of drug to the drug target. Absolutely right. So action of the drug molecule to the drug target, right? So can you tell what are the functional groups in this can interact with the drug target? Because we already discussed about the various types of interaction, if you remember, right? Do we discussed or not? Or different types of interactions. Like covalent interaction, ionic interaction, hydrogen bonding interaction. Do we discussed or not? See, the problem for me is you are taking too much time to respond. Am I audible? Aishwarya?
Yes, sir.
Am I audible?
Yes, sir.
Did we discuss anything about the different types of interaction in any of the lecture or not? That's my
No,
question. No, okay. I don't know why you people take too much time, right? Okay, no, okay, fine. Okay, so at least you people have, very basic idea of about different types of interaction, covalent interaction, ionic interaction, hydrogen bonding interaction. Say, for example, this functional group, as I did not discuss already, right? So I am telling the answer. This functional group can participate in hydrophobic interaction. I'll teach you later, right? So what is meant by hydrophobic interaction? So this can participate in hydrogen bonding interaction, and this group can participate in hydrogen bonding interaction. This group can also participate in hydrogen bonding interaction. This can participate in hydrogen bonding interaction. Okay, this can either act as hydrogen bond acceptor. Also, there is possibility for ionic interaction if this group exists as O- ion. Okay, there is possibility for ionic interaction also, and this group can participate in aromatic interaction. Okay, so these are the possible interaction for this molecule, right? So again, these interactions are very important for the drug action, because we know that the drug molecule should goes and bind to the receptor to produce the drug receptor complex, and this interaction lead for the formation of complex that lead for drug action. So even pharmacodynamics of the drug molecule, which depends on the types of functional groups which are present in the drug molecule, right? So with that background, I just want to go to this slide. Okay, I'm not going to discuss very complex functional groups, right? I just wanted to discuss the very basic functional groups which are present. Any functional group is present, or what's the name for this class of molecule? Can we say it as alkane?
Yes, sir.
Am I right?
Yes, sir.
So what are alkanes? Alkanes are basically they are made up of only carbon and hydrogen. So in this molecule you can see only the presence of carbon and hydrogen. So you cannot find any double bond. All the bonds will be single. Hydrocarbons, right? So which are made up of only hydrogens and carbons. So cyclic structure is also possible. We can form cyclic hydrocarbons. So if you take cyclohexane, you cannot find any double bond. Again, the compound is just made up of carbon and hydrogen. Those are example for cyclic hydrocarbons, right? Cycloalkanes, those are called as cycloalkanes. So let me draw the structure of cyclohexane here. I don't know why it's not working. Okay, it's not working, right? So alkenes, right? So what are alkenes? They are also hydrocarbons, but the difference between alkane and alkene is, in case of alkenes, you can find a double bond. You can see here a presence of carbon-carbon double bond. So we cannot call this alkane. This is alkene. So your drug molecule may have alkane functional group, or it may have alkene functional group. Meaning is that the carbon-carbon double bond, presence of carbon-carbon double bond, right? So here, what's the name for this group? Can we call it as a hydrocarbon? This region.
Yes, sir.
Okay, so this functional group should be called as alcohol, right? This functional group is alcohol. So if your drug molecule is having presence of OH group, then that should be called as alcohol, right? So this OH functional group should be called as alcohol functional group. Again, we can classify this alcohol functional group into a primary alcohol, secondary alcohol, and tertiary alcohol. So can you tell what is the difference between primary, secondary, and tertiary alcohol? All this you studied in your 10th standard organic chemistry. Actually, I'm not teaching anything new. Can we classify this alcohol into 3 types?
Yes, sir.
Yeah. Can you tell what is the difference between primary alcohol, secondary alcohol, and tertiary alcohol?
Primary alcohol is the one that is attached to primary carbon, and secondary is secondary. That's it.
Okay, it's very general answer. I don't understand. Any other answer? Yeah, what you said is right. I need a little more clear answer. What is primary carbon? What is secondary carbon? In this carbon is primary or secondary?
It is a secondary carbon, sir. I think, I'm not sure.
Okay, any other answer? Whether this is a primary carbon or secondary carbon?
It's a primary carbon.
It's a primary carbon. Then which carbon is secondary carbon?
The carbon next to the OH group.
Huh?
The CH2 one.
This one.
Yes, sir.
How do you say this is secondary?
The carbon which is attached to the OH group is the primary carbon. And the next one is
if I attach this OH, if I replace this hydrogen and this OH, hydrogen to this position and OH to this position, can we call that as a secondary alcohol? Again, I repeat. So I am going to replace this hydrogen to this position and this OH to this position. In that case, can I call this OH, presence of this OH at this position, as a secondary alcohol?
No, sir. They're not
okay.
become primary only, sir.
That's my question, right? So you have to think of what is the difference between primary, secondary, and tertiary alcohols, right? So you may take it as a homework, right? So few questions I won't answer because these are very basic. You should know, or you have to explore on your own, right? So as a BTech student, you could able to tell what is the difference between a primary, secondary, and tertiary alcohol, right? So I think somebody wanted to answer. Anyone?
Sir, the carbon which
Yes.
has the OH group, how many carbons it has in surroundings? It has the carbon.
Absolutely right. How many surrounding carbon atoms that decides whether it is a primary, secondary, or tertiary. What he said is right. Okay. Anyway, we will see a lot of examples, right? So no need to worry about that. So what is this functional group? Already we discussed about OH, right? What's the name of the OH functional group?
Alcohol.
Just now has shown.
Alcohol. Sir.
Alcohol. So can we call this as alcohol here? If OH group is attached to a phenyl ring, we should not call it as alcohol. Okay, it's a kind of phenol. So this functional group is called as phenol functional group, right? So only one oxygen you can find has only one OH group. So and the OH group should be directly attached to the benzene ring. That's a basic criteria to call that functional group as a phenol, right? So what is the name for this C6H5?
Phenyl.
it should be called as a phenyl. Okay, whenever I'll be showing, from the next class, a lot of drug structures. So whenever you see that C6H5, you should not call this as benzene, right? So C6H5 is not benzene, it is phenyl functional group. Any idea what is this functional group?
Aldehyde.
So what's the general structural formula for aldehyde?
CHO.
R
RCHO.
C
RCHO.
or CHO or COH. Okay, so this is R COH, right? So it's the general formula for aldehyde. You are right, this is aldehyde. So if you take any aldehyde, you can find only one oxygen atom. So here we have only one oxygen atom. So this aldehydes will be having C double bond O group, right? So that's carbonyl group. Okay. So there should be hydrogen attached to this carbon atom, right? So if it is anything other than hydrogen, we cannot call it as aldehyde. Okay. So any idea, right? So do you remember aldehydes can be easily oxidized? So whenever you have the aldehyde functional group in any drug molecule, they can easily undergo oxidation. So oxidation is one of the primary reaction in metabolism. So can you tell, if we oxidize this aldehyde, what will be the resulting product?
Ketone, sir.
Already I defined what is, no, you have to remember, already we mentioned that we defined what is metabolism, right? And also we defined what for the metabolism is taking place. So the question of, interest is, if we oxidize any aldehyde, what will be the resulting product?
Carboxylic acid.
Carboxylic acid. Yeah, any more answer before checking the correct answer? So one answer is carboxylic acid. Huh?
Carboxylic acid.
Everyone goes with carboxylic acid. Okay, that's right. Okay, so what will happen? This hydrogen will be replaced by which group? OH. Okay, that process is what is called as oxidation, right? So this group will be converted into OH. Now aldehyde, acid. If you compare aldehyde with acid, which one will be more water soluble? So assume that you have two compounds now.
Acid.
Acid. Are you able to understand? Acids are more soluble. Why? Because you are adding one more polar functional group.
Hydroxyl.
Which polar functional group? OH. Make sense?
Oh.
Okay, so we are the oxidation is the process which converts the less water soluble aldehyde into more water soluble carboxylic acid. Okay, we'll talk about that later. So any idea what is this functional group?
Ketone.
So this is ketone. What is the general formula for ketone?
Ketone.
What is the
RC double bond.
RC double bond OR. You are right. Okay, so the general structure is here also you'll be having only one oxygen. So the oxygen is directly connected to carbon atom. Okay. So this is a question, right? So ketones cannot easily be oxidized. So what is your opinion? Yes or no? Aldehydes, they can easily undergo oxidation. Ketones cannot. Is this statement right or wrong? If it is right, why?
So due to steric hindrance, I think.
Steric hindrance. You can compare the structure of aldehyde and ketone. It itself has the answer. What is needed for the oxidation? Okay, it's a kind of lack of.
Sir,
yeah. Yes.
The hydrogen.
What he said is right. No. What he said is right. He answered right. So let's finish that. So no hydrogen atom attached to the CO group directly, right? So that is a basic criteria here. The carbon is directly attached to the CO, which cannot undergo oxidation, right? So we need hydrogen that is directly attached to the CO group. There is no such group in this functional group, so it cannot easily undergo oxidation, right? So which means that if your drug molecule is having this ketone group, we cannot expect that molecule to undergo oxidation during the metabolism process. Those I'll be teaching later, right? So in very detailed way, right? So I think time up. Can we wind up the session?
Yes, sir.
Yes, sir.
Yeah, okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.